So this video is section 3. We're looking at functions and their graphs. And specifically we are discussing what a function is. When we're looking at a function, we're looking at some rule that takes one element and maps it or matches it with another element. So there's a couple ways that we can express this. I'm going to show you first with a mapping diagram. So let's say we've got a set of values over here, and then we've got another set of values or numbers over here. So we might have a guy in here, let's call it, I don't know, the number 3. And 3 might be paired up with another number over here. I don't know, let's call it 9. So there's some rule that discusses how we get from this value over here, which we usually call the x, to this value over here, which we call the y. Now, it might not be an obvious rule. Now, you're looking at this, you're thinking, well, it's probably the squared rule. And so if I put this in here, now it's no longer the squared rule. Okay. I mean, who knows what the rule actually is? All I know is that if I take the function and I evaluate 3 into it, or I evaluate it at 3, I get 9 out. And if I take the function and evaluate it at 2, I get 7 out. Okay, so this is the notation. This is what we're going on. So that's a mapping diagram. Actually, before I stop talking about that, let me say a couple of things. This set over here is called the domain. Okay, it's the values that we get to use. And typically, those come from the set X. Now, usually when we talk about a set, we talk about an uppercase letter is the set, and the elements that is inside it is lowercase. So large X is the sets for the domain, that is the domain, and then small x, it's hard to write the difference between those are the elements or the items in X. Now this one over here, we're going to call Y. Just like I've got up top, so this is going to be the range. Now we have to be careful with how we discuss the range versus what's called the codomain. A range, that's the exact values. That's all the values that can be output in a function. It's all of these guys over here. The codomain is a set that we map onto, but we might not use all of them. Let me give you an example of this. So let's say we've got a function f of x, which takes a value, and it takes the absolute value of it, okay? So it finds this distance from 0. Well, if you take a look at this, we might take the real numbers and we want to map them also onto the real numbers. So like the number 1 comes over here and it maps onto the number 1. The number -1 also maps onto 1, and that's fine. Okay, there's nothing wrong with that. Inside of this codomain is a subset, and that subset is called the range. So the range are the actual values that we see as outputs to the function, whereas the codomain is just something that we're mapping onto. So for example, all of the real numbers for the codomain, that includes a number like -2. -2 is in the set of real numbers. And so the codomain of this function could be the real numbers, whereas the range of this is going to be all the non-negative numbers. Now, what makes a function a function? So far what I've described are just relations, but what makes a function unique is that with a function, if you have an input value into a function, you have to know exactly what the output value is. Like, for example, if I have a function f of x is equal to x to the third, if you ask what is f at 2, I know what's going to come out here. Well, 2 to the third, which is 8. However, if you give me a function like this, f of x is equal to plus or minus the square root of x, and you ask me what is f at 4, the question is, I don't know. It could be plus 2 or minus 2. And since I can't pick between the two of those, since I don't know which one it is, okay, it could be one or the other, that makes it not a function.